Question 11 is actually question 1 of the short response questions. So question 1, determine the derivative of each of the following with respect to x. So here we can solve this using the chain rule, which is dy on dx equals dy on du times du over dx. We can let u be sine of x, and so du on dx will be cos of x. So just a refresher, sine, cos, negative sine, negative cos. When we are deriving, we go downwards, which means derivative of sine x is cos x, and derivative of cos x is negative sine x, derivative of negative sine x is negative cos. When we are integrating, we go upwards. All right, so knowing this, we can write our y as 1 on u, or u raised to negative 1. And our dy on du is going to be negative 1 u raised to negative 2. This is using the power rule differentiation. And this is the same as negative 1 over u raised to 2. So we can get rid of the negative 2 by bringing u squared to the denominator. So let's rewrite this now. So dy on dx is going to be dy on du, which is negative 1 on u squared, times du on dx, which is cos x. That's negative cos x over u is sine x, so we can change that to say that. Part B. So we're differentiating part B. So we're differentiating y equals x squared times e to the negative x, and we want to present the answer in a factorized form. So because we've got two terms being multiplied, we can differentiate this using the product rule, which is y dash equals u dash v plus u v dash. And we can let u be x squared, and then our u dash will be 2x, and we can let v be e to the negative x, and our v dash will be, so we times it by the derivative of negative x, which is negative 1, e raised to negative x. So this equals 2x times e to the negative x plus x squared times negative e to the negative x. That is 2x e to the negative x plus minus is minus x squared e to the negative x. And we want to put it in factorized form. So the common terms between this and this are x and e to the negative x. So we can bring that to the front. And we have 2 left over here. And we have x left over here.